Hello all. I'm taking your time to hear some informations regarding synchronous machines. So basically what is synchronous machines? Machines runs at constant speed is known as synchronous machines. Synchronous machines are of different types. Basically I'm taking the time for hearing about one of the synchronous machine type, that is synchronous generator or AC generator or alternator. So what is basically a synchronous machine? And the synchronous generators or alternators are used to convert mechanical power derived from steam, gas or hydraulic turbine to AC electric power. And also, synchronous generators are the primary source of electrical energy we consume today. Large AC power networks rely almost exclusively on synchronous generators. And synchronous motors are also there, and they are also built up in large units compared to induction motors. That is also a kind of synchronous machines that is cheaper compared to the alternators, and also they are having smaller ratings and used for constant speed industrial drives. That is, induction motors are used in industrial applications. And these machines are designed, that is synchronous machines are designed to be connected to the supply and run at synchronous speed, that is constant speed. That's why they are known as synchronous machines. Then the synchronous generators is also referred to as alternators, and also it is known as AC generators. The principle of construction and operation for alternators and synchronous motors are almost similar. And basically that EMF generation, that is the main component in the construction and operation of the synchronous machine. We all know the scientist Michael Faraday. He is known as the father of electricity, and he discovered electricity in 1930. So what is basically an EMF? EMF as an equation we get as d phi by dt. And this direction of induced EMF is given by the Fleming's right hand rule. So what is that right hand rule denotes? If we are extending our fingers for thumb, forefinger and middle finger, the forefinger shows the direction of magnetic field and the thumb shows the direction of motion of conductor, that is the direction of induced EMF, and middle finger shows the direction of current. And these synchronous machines, that is synchronous generator or alternator or AC generator, is also consist of two main parts, that is stator and a rotor. In the main difference between a DC generator and an AC generator is the construction of stator and rotor. In DC generator, the stator is the field magnet and the rotor is the armature winding. But in the synchronous machines, that AC generator side, the stator is the armature and the rotor is the field. And the stationary armature is placed in slots of stator core, and the stator is made of lamination, and this whole stator is fixed in the stator frame. And the rotor is the field winding, and this field winding, for excitation we are giving an external DC supply of 120 to 600 volt, and supply is by is through brush and slip ring, and this North Pole and South Pole developed alternatively, generating the sufficient electricity. And I earlier said that the basic difference between the AC and DC generator. So I repeat it once again. In DC generator, armature is rotating and the field is stationary. That is, the rotor is armature winding and the stator is the field magnet. And in the AC generator side, the armature winding is the stator, that is the stationary part, and the field magnet is the rotor or rotating part. And the advantages of alternator, that is AC generator over DC generator. First one is generation of power at high level and also easy to collect high current and no commutation, easy to provide insulation and cooling in stationary armature. So this is the main advantage of the stationary armature in the case of the AC generator. And also low voltage level in field, so less insulation required. Thank you.